So I guess we're ready to start. Thank you all for joining this session today. And in this session, we will focus on how to build Apex triggers so that they can cope with large data volumes and changing requirements. So in other words, we're focusing on best practices on trigger implementations. My name is Miika Rintakoski, and I work as a solution architect on Finnish media company called Sanoma. And before that, I used to work as a consultant focusing on custom app development on the Lightning platform. To begin with, we have the forward-looking statement slide, so don't make any purchasing decisions based on anything that I will be saying today. So we will start on looking at why the triggers perform badly so that we are able to identify that what causes the inefficiencies and where we can improve. So what in practice are the means to improve the performance. We'll be mainly focusing on SOQL and DML operations because those tend to be the ones where we make the most crucial mistakes and which degrades the performance. Then we'll be looking at the large data volumes, and that, in a sense, is not a reason for a trigger to perform badly, but it tends to show us where we have these implementation mistakes. And then we're talking about changing requirements, and overall, I think that when we do trigger implementations, we are not considering the solution as a whole, but we're implementing individual features, and those then tend to degrade the performance in the long run. To improve the performance, we'll start off with the bulk triggers. I hope you're all familiar with those, but anyway, let's cover it briefly before diving deeper into a couple of additional design patterns that we can use to improve the performance. And starting off with what causes bad trigger performance. So performance overall is not something that you add on top of the features that you have implemented. It's of course something that is built into everything that you do on the platform. And that's the responsibility of each and every developer operating there. But how is the bad trigger performance then brought into the solutions? So as mentioned, DML and SOQL are the one things that tend to degrade the performance, and we tend to use them quite loosely. So we update records that are not needed, we update them several times, and that of course requires additional upgrade operations, additional CPU time, additional queries, and so on. And the same applies for SOQL. So we query records that we don't need, we query them several times throughout the trigger execution, even though they could be queried only once and reused in several places. And of course, they are bad because disk input and output is slow overall. But of course, queries are something that you can do really badly as well. So if they're not selective enough, if you don't have proper indexes there, that will degrade the performance in a single query quite significantly as well. And the last bullet point, that whether DML is evil, I think we need to go a bit further. So basically, this same question was raised last year here at Dreamforce. Kevin Poorman, developer evangelist in Salesforce, asked the same question around Apex testing. And there the conclusion was that DML is not necessarily evil, quite often maybe unnecessary, but not evil. But it's such a powerful tool that you should really think that when to use it, especially because there is a lot of things going on when you do the DML. So DML triggers everything that you have up for a given object. It might be a single line of code in your trigger, let's say update a list of records, but in a sense it runs all the process automation, all the triggers, all the workflows, all the processes, and then all the validation, duplicate rules, whatever you have set up. So even though it's just a single line of code, it's a lot of things going on. Yeah, sorry, my voice is a bit down due to the flight on Monday, but I'll try. I guess you have, at least most of you have visited the developer resource that's linked here, but this is pretty much everything that is going on when you run your DML statement. And to highlight mainly on the blue sections in the diagram, so the system runs all the before triggers and of course, all the DML or the SOQL that you have set in the before trigger. Then there is this system validation, custom validations, all the after triggers, and again, all the SOQL or the DML that you have there in place. And keep in mind that all the DML that you have in those triggers will, of course, run this very same diagram from the start for the other records. Then if you have workflows in place, then, and in the workflows, if you have field updates, then it starts to execute the triggers again. So working on the before update triggers and after update triggers and getting back to the workflows again. When we get done, when we're done with this workflow and trigger update cycle, the system updates the rollup summaries, which can force the parent record to go through the same procedure, and the same goes for the grandparent records as well, if they're present. Single line of code, update list of records. So to improve the performance then, let's start off with sort of basics. So what can we do on every feature that we implement on those triggers? How to improve the performance there and how we can make them go with large data volumes. And with large data volumes, I mean volumes that are relevant for performance. So it could be millions of records on a nightly job, or it could be actually 200 records updated from the user interface. That's important for the user's experience on the performance. I'll be showing a couple of code examples. So all the code will be available on GitHub. So no need to try to get those on screenshots. We start off with the bulk triggers. I hope that all of you, if you are implementing triggers, you are familiar with the concept. But basically, it means that the trigger should always operate on all the records that are present in the trigger context. And you should not have queries or DML operations in the loop, but instead you should operate on collections of records when you're doing the operations. And if you're not familiar with the bulk triggers, I propose that you check the material on Trailhead. Then, to move further, let's set up an imaginary scenario which states that when the order status is set to confirmed, we update item status in the related order items to confirmed. So pretty basic master detail data model, and quite often seen use case where the update on the master record forces the update on the detail records. And we have the example implementation there. Okay-ish, I would say. It's bulkified. We are doing the queries with the list of records. We are doing the DML with the list of records. So in that sense, seems to be okay. Let's review the first pattern, and then let's see if there is something we can improve. So we should detect changes in the triggers. So in a sense, there is no configurable precondition on the triggers. We can, of course, state that what is the event that the trigger reacts on, but basically nothing else. In the declarative automation, we have this possibility to use the isNew and isChanged functions, but in a sense, there is no similar concept in Apex. But we should build it in there. And with change detection, we should enforced that we only run the logic on the records where we need it. And in that way, we're able to avoid unnecessary SOQL and DML operations. And it's good to keep in mind that this has an effect on the way that the trigger behaves, but usually for the better. But we'll review the impact on the functionality a bit later. So here, looking at the example again, the issue is on the line 22. So we're just checking that the order status is confirmed, but we're not checking that whether it was changed to confirmed. So pretty much any change on the order would run all the confirmation logic on the order items as well. So we could implement something like this to overcome it. So in this way, we're checking that whether the record is new, which is usually relevant for similarly relevant as changes. And then we're checking that the status was something else than confirmed earlier. But in the long run, when we start to pile these up in the implementation, it starts to corrupt the readability, I would say. So I'd propose that we set up some kind of a utility method that we can utilize throughout the implementation. And there it's easier to see then that, or easier to read that what is the condition. So order status is confirmed and the order status was changed. And as mentioned, this has an effect on the functionality. So before we had the change detection in place, any change on the confirmed order would run the logic, meaning that even if it's something like order description or any other field that is changed, we would have run this logic. All the queries, all the DML, and that's usually not what we want. And after the change detection, only the status change to confirmed is running. Next pattern, validating query parameters. This is actually quite simple, but there are cases where we can detect in advance that whether the query will produce any results or not. We can check, for example, that if we're trying to query with an empty set of IDs, for example, then there would for sure be no results from the query. We can also check that there is not an invalid value that we're trying to query with, and in that sense, avoid querying for no reason. Main benefits, less queries, this is pretty evident, but also better readability through better structure. And in a sense, this has no effect on functionality because it really doesn't matter if you're querying if there will be no results at all. And looking at the example, so starting off where we finished with the previous pattern, we have only one query, but we are not checking anyway that if there are confirmed order IDs or not. So we're just executing the query. There will be, of course, no results if the set is empty. And the diff may not be the clearest one, but the relevant change is on line 26. So we're checking that if the confirmed order IDs is not empty, and only then run the logic. All right, let's continue with the same scenario, but let's highlight one thing about it. So what if order items can be confirmed on their own, so that we are not requiring that the order is confirmed before we confirm the order items? And for that one, I'd propose that we validate updates. So before update, we check if the record even would be updated with the DML operation. And of course, main benefit is that if we use less DML, we have less everything as discussed in the beginning. And how to do that? Here's one example. So we are already in the query, just getting the order items which are not confirmed, and only then working on those. This could be done within a loop as well. So if we have queried the order items for some other purpose, then that's of course perfectly fine to do that there as well. But this is maybe the simplest way. But what about changing requirements then? So previously, the things or the patterns that we had a look in earlier, they apply to pretty much all the features that we implement. But for the changing requirements, we need to think about the solution as a whole and not focus on the individual features. So jumping back to another scenario, this time a bit different. So if the order has priority set as high, we create new order items automatically with this quick delivery checkbox checked. So also quite common scenario. So we have a master object which steers the creation of the detail objects. And there is also an example implementation for this one. But if we, let's say, a few months later, come back with another requirement which has a similar structure. So we have a payment method on the order, and if it's prepayment, then we create the new order items automatically with this delivery on hold checkbox as checked. And probably the implementation would be so that from the trigger controller or similar, we then call the feature-specific methods from there. And this is the implementation for the feature method itself, pretty similar to the one that we had for the previous feature. But when we start to implement the features in this sense, we start to query the order or the parent order in all of the feature methods, and that's of course pretty unnecessary. So we should avoid that. We should query all records from one object at once if possible, all the records that we need, and we should cache those and utilize the cache in the subsequent feature methods. And if this is implemented properly, then the caller does not need to know about the cache, or at least it doesn't need to know whether the record was retrieved from the cache or from the query. And this does not have any effect on the functionality as long as we invalidate or update the cache when the records in the cache change. We will cover that after a while. And this works really well on the scenarios where we have the master record controlling the creation of detail records. And main benefits for the pattern is less queries and it's easy to extend. So easy to extend means that it helps us build solutions that last throughout the application lifecycle. To implement this, I have here declared a separate class. It could be implemented in many ways, but basically the cache here has a query parameter, and then the cache itself, which is mapped from the record ID to the record itself. And then the important part for caching is that we have a get method to retrieve the records, and that does the heavy lifting. It either gets the record from the cache if they're cached already, and if they're not, then it runs the query and puts the queried records to the cache, and then returns the results. And to use it, of course, we need to define the cache in, let's say, static variable, so it's available throughout the trigger runtime. And it's good to keep in mind that to cache the records, we need to query all the fields that are needed in the feature methods. So we're not able to, in order to use it throughout the solution, we should have all the fields there. And then we replace the actual queries in the feature methods with the calls to this get method, and that then does the record retrieval. And already in this case, we are able to limit the query count to half. And of course, the more this kind of features you have, the more it has impact on the performance. But it's good to keep in mind that if you cache something, there are changes that will make your cached records outdated. So it could be that from the order item trigger, we somehow trigger an update to the order, and that then makes it outdated. But we should, in these cases, either invalidate or update the cache in order to keep it up to date. But in a sense, it's usually enough to just remove, on the update of the cached record, just to remove it from the cache so that it's then re-queried the next time someone tries to use the cache. Then moving onwards with the scenarios, so this is in addition to the scenario that we had on the first patterns. So when delivery status of an order is set to in transit, we set the delivery on hold checkbox on order items as false. Similar scenario, data flowing on an update from the parent record to the detail records. Similar implementation as before. So we have a trigger controller where we are trying to have the feature methods separately, and then in the feature method we would have this kind of an implementation. So pretty similar as the one that we had with the statuses. We have all the things in place that we applied for the initial requirements. So we have change detection on line 47, on line 51. We're checking that there would be results from the query that would affect the functionality. And then in the query itself, we are only getting those items which are not already on delivery on hold. And then to overcome this issue, so if you look at still briefly at the example, so here we are also updating the items. And we were updating them from the other feature method, from the confirm order items as well. And to overcome this issue, I propose an approach where we try to combine these DML operations together. So we are not running DML from each and every feature method, but instead we run the DML on a single operation. And this, of course, have a major performance impact because the DML was the, I would say, main cause for bad performance, and with this approach we're able to avoid a lot of those. So here the proposed way is to cache the updated records throughout the trigger running, and only after we have run all the update relevant logic, we then do the actual database operation. And this is again keeping in mind the changing requirements and the way the solution evolves over time. So this is then easy to extend, so easier for developers to keep on adding features without compromising the performance. An example implementation, so again, encapsulated in a proper class. We have two methods. One, which caches the records for the update. So in a sense, we put the records into the cache, and the changes that we have made to those records, we put them there, and then we have a separate method which is then called when we are ready with all the updates and when we want to push the changes to the database. So somewhat similar to the query caching, but this time for update operations. And then when we want to utilize the DML cache or the update cache, we replace the actual DML operations that we had. We replace them with the calls to this cache. So we push the records that are going to be updated to this cache, and then when all the feature methods have been run, then we run the actual DML operation via this function call. So this will help us in reducing the DML statement count. All right, to summarize, so performance is not something that you add on top of your feature, it's something you build into those. So it's good to keep in mind that you as developers are responsible for the good performance. And in a long run, trigger is not the place to take technical depth on, but instead try to keep the performance in mind right from the start. And as discussed, DML and SOQL operations are the most crucial ones for performance. So try to introduce these concepts into your triggers to reduce the bad impact they have on the performance. So bulk triggers, the very basics. Change detection to avoid running unnecessary logic. Trying to predict in advance if your query would produce any results, if your update would produce any results. And then these two caching concepts, so caching the queries and caching the update operations, so you're able to combine those and reduce the count of both in your implementations. So as mentioned, the source code samples are available in GitHub, so you're able to check them from there. All the diffs are available in commits, so you'll be able to quite easily follow that what was applied at which stage. And then there is the links that were earlier in the presentation, so the developer guide about the triggers order of execution, and then the Trailhead module about bulk triggers to get you started with. But yeah, thank you all for joining for this session, and if you have any questions, thank you.